So odor and taste. So these are the last physical impurities that we have to study, that is odor and taste. So these are closely related to each other. So we'll be studying this both in detail. So among these physical impurities, we have covered the first three: temperature, color and turbidity. Now we will be seeing odor and taste combinedly. Now, so odor and taste, if we try to sum this up in one statement, then we can say that there is a taste for odor. Okay, there is a taste for odor, but no taste for taste. So write it down. There is a taste for odor. That means we can find odor by doing some taste, but there is no taste for taste. So don't get confused. This taste is the taste that we are talking. Okay. Now these two are closely related to each other. What is generally done is first we find out what is the odor level of the water. Okay, if it is foul, or we can say if the odor is objectionable, then we assume that the taste is also bad. So first we'll find out taste odor. If the odor is objectionable, then we will assume that taste is also objectionable. So write down this. If odor is objectionable, okay, so if odor is objectionable, then we assume taste is also bad. Taste is also bad. Now, so how odor is measured? So is measured odor is measured by a device called by a device called osmoscope. By a device called osmoscope. It is expressed in terms of TON. Okay, TON, and this stands for threshold odor number. Threshold odor number. So how to find out this threshold odor number? So this threshold odor number, actually it is a dilution ratio. Okay, it is a dilution ratio. That means we are diluting something and then we are taking the ratio of it. So the formula for TON calculation is threshold odor number is equal to A plus B by A. A plus B by A. So it is a dilution ratio at which odor becomes objectionable, or we can say in this case detectable. So if there is certain foul odor that is detected, then that will be the point of the dilution ratio. So in this formula, this A stands for water sample in ml, and B stands for distilled water used in dilution, and this is also in ml. So one thing that you have to always keep in mind while doing this is this A plus B summation, that is A plus B, this should be equal to 200 ml. This should be equal to 200 ml. So slowly you will be taking one by one sample. You will be calculating the TON value. You will change the value of A. If this TON number is greater than 3, that means it is objectionable. So the general range of TON, that is threshold odor number, so it is between, or it should be between 1 to 3. 1 to 3. So this is all about odor and taste. So once again we'll revise. So generally this odor and taste, these both are related to each other. If we take a water sample and if there is odor present in the water, then we have to assume that the taste is also bad. That is taste is also objectionable. This odor is measured by osmoscope, and the value of odor is measured in the terms of TON, that is threshold odor number. That TON is calculated by the formula A plus B by A, where A is the given water sample. That means we have brought certain water sample 10 ml, 20 ml, so that will be the water sample value, and D will be the distilled water used in dilution. So let's say dilution means we are just adding the water, distilled water, more and more. That means we are diluting the combined mixture. One thing should be common, that is A plus B should be equal to 200 ml, and this odor threshold odor number should lie in between 1 to 3, this TON value. If it is greater than 3, then we have to reject this water. So these are all the physical impurities that we have studied, starting from temperature, color, turbidity, odor and taste. See, one more point that you can keep in mind is that these physical impurities do not cause any health problems, okay, or we can say not any severe health problems, but just due to human psychology we have to remove it. Let's say the color. See, the color in most of the cases it is not hazardous to human health. But what it does is, if there is certain color in water, and let's say if we are washing the white shirt that you have, then what will happen? The white color will get, or we can say whatever the color of water is there, that will be imprinted on the white shirt. So such kind of problems can come. But however, color itself is not hazardous to human health. That means if certain water has some color, let's say yellow color is there, then it is not necessary that it is not a wholesome water, that it is not a drinkable water. So similar thing is applicable to all the other physical impurities. Okay. So now from the next video, we'll start the chemical impurities, and this is a long list, but we have to complete each and everything, and with along with the whatever the design standards are given.